Hey, welcome to Statistics Part 3. This video will take us through to the end of the requirements for the national curriculum to the level of Year 8. So hang on to your seats, let's have a go now. And what I'm asking you here is, where do you think we would go next? Okay, where to next with all of this graphing and calculation of statistics that we've been doing? And the question is, what if you have heaps of data? You might actually have to start grouping them and handling them in a slightly different way. But come up the top of the screen here now, and let's have a look at all this data set here that we've got. These are people's favourite seasons of the year: autumn, winter, spring, summer. And you can do this, can't you? You can tally them up, put them into categories, and draw a nice vertical column graph over here. And don't forget to label the axes, frequency, and have a proper scale here going up the y-axis and the season along here, and gaps because there is nothing between autumn and winter. Okay, so we just have columns representing those single categories. So here it is down here also with a pie chart. So I hope you've mastered those skills, and actually you can also calculate the mean and the median, the mode, and work out the range. That's where we're at so far. So in the bottom half of the screen down here, look at this data set. Lots of numbers. People don't like looking at lots of numbers. They can't work out what's going on. These might be the number of cars in 8 till 9 o'clock in the morning going past your school, something like that. And we've calculated over 30 days to see how busy that road is out the front there. Well, what can we do with that? Well, we could put it into a stem and leaf plot like this one here. Let's go back there. Oops. Hang on, where are we? There we are. Stem and leaf plot there. We could do that. And that has all the data set, but it's sort of grouped, isn't it? It is being grouped because here are the ordinary numbers, and then there are the tens, so this is 13, and the 20s, 22, the 30s. So it's sort of grouping them, isn't it? But in a number way of single units, 10s, 20s, 30s, etc. And or we could do this. Now, you haven't done this before. We could group the number of cars from 0 to 9, from 10 to 19, and we could draw a slightly different looking graph here, still a vertical column graph. And we've got gaps going from 0 to 9, 10 to 19, because there's nothing in between 9 and 10. So we could still make it a separate column, separate categories there, but they are groups this time, they're groups. And so we'll have to look at how we would handle that in terms of calculating the mean, the median, the mode, and the range. So we're going to do a bit of revision, and we're also going to go on a little bit to look at this group data when we have lots of scores. Okay, so let's come on down now, and here we have it. What are we going to do? Here is the school data, or data, whatever you want to say, and we're going to put it into categories. So we're going to call the first category 0 to 9, etc. Just remember, read the data set only once. So 27, and you put one in this group. 30, and you put one in this group. And you tally it up. So scan the data only once, mark a line through it as you record it, and so on. And every fifth one you make a bundle of 5 like that. Here they are, so it makes it easier to count up how many you've got rather than a lot of single lines, gets confusing. And then you have a frequency column, 1 in the first group, 5 in the next, 10, and you total them up. Okay, so we've done a bit of that. And then, of course, we've got a nice graph. It should have a title, should have axes labels on both axes here, and a scale, proper scale here. So each of these can be read off accurately. Okay, so we're really making a more sophisticated graph now than what you might have done in the past. And over here, a stem and leaf plot. You know what to do there. Again, you look at the lower score, which is in the ordinary digits, 9, and then go up from there. Okay, the 10s, 17s, 13s, 18s, the 20 up to 50, because you find your biggest score here, which is lurking in there somewhere, which is 52. So you know you've got to go up to the 50s there. Then again, the same thing. As you read 13, you put it in the 1, because the 13, 1, 10, and 3 units. Okay, so this is a form of grouping data, isn't it? And there we have it. That's just doing the first recording, and then we would rewrite it down here in order. So it goes up 9, and then it's 13, 16, 17, 18, 18, and that wasn't in order up here, was it? So we rewrite it in order. And you're going to see why later on. You might also be able to work out right now why an ordered stem and leaf plot, apart from being a bit more organised mathematically, why it might be useful in calculating the mean, median or mode. Why might it be more useful? You might be able to have a look at that, and also to find the range. So think about why you might order a stem and leaf plot. Okay, let's go on and see what we can do. So here we are, the ages of people at a 21st birthday. Draw a stem and leaf plot for the data. Redraw it so it's ordered. How many guests attended the party? How old was the youngest? How many were at least 30 years old? What percentage of guests were in their 20s? So a stem and leaf plot's going to be good for that. So let's go and do it. So you'd go 22. So first of all, well, what's the lowest age group there? It's in the 10s. I think it's, where are we? Going through. It's 16. And then the oldest person is 48, I think. 49. Let's see here. 48, 49. So we will go from 1 to 10s, 20s, 30s, and their 40s. And then when we see 22, we put that score in. Down here, 22, 20 will be a 0, and you've got the idea. You're labelling all those. Don't forget the scale here. 1/8 means 18. Then over here, we're going to put them in order. So we're going to take this list of scores here and put them in order. So that's that row there. And do it with each row. So how many guests attended the party? Well, up here we could add them all up, because what have we got? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 rows of 12. Remember, multiple addition. Don't do multiple addition. Do multiplication. That's what it stands for. 24, and that one is separate. 25. So we have 25 guests attended the party. And the youngest guest, well, we just got to go to the bottom of the stem and leaf plot, don't we? Because we put it in order. There's a good use for an ordered stem and leaf plot. 7 guests were at least 30 years old. So this is bundled up here. At least means 30 or more. So there are 7 of them. What percentage of guests were at least 30 years old? So it'd be 7 out of 25 times 100, wouldn't it? If you want a percentage. How many guests were in their 20s? Well, here we are. We can go to this group here and total them up. There are 11 entries there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 guests were in their 20s. I'll come back here. And the percentage of guests were in their 20s, 11 out of 25 times 100. You could do that, couldn't you? 25 into 100 goes 44%. So don't forget some of these basic skills. You can use a calculator, but you want to keep your brain cells active as well. Okay, so how are you going with that? That's just a bit of revision, I think, really. So here, try yourself on this set of problems here, 18C. We'll put a tick on the wrong screen there. So pause the presentation, have a go. You may not have to do all of these, because some of them we've done before, not this exact problem, but ones like it. So just make sure you've got the skills and then go on. So let's have a look at the next page. And there are 8 problems. So you wouldn't do all of them. Try some of them and make sure you check your answers as you go. So pause it and have a go. I'll show you the answers now. There's the first 3 problems, and then up to question 8. So watch the stem and leaf plots. They are important for later on. You might like to start thinking, well, how would you find the median? Because the scores are all put in a certain order, aren't they, with the stem and leaf plots from the smallest to the largest. Could you work out how to find the median? We'll learn that later, but you might be able to work it out for yourself now. All right, so come on down now. So what we're going to do is do a bit of revision of how do you measure the centre and spread of this data set. So what's the mean again? The mean is the sum of all the data values divided by the number, and we have symbols for that. You're not too young to know this. Sigma means sum of all the scores over n, or if they occur more than once each, don't forget to add up the number of times they occur times the score over n, multiple addition, multiple lots of something times by how often they occur rather than add them all up separately. Right, so I think you can start using those symbols rather than the words. Look how bulky the words look compared to our nice mathematical symbols here. Okay, what's a median? The median is the middle value when you put it in order of an ordered data set. So for an odd number of pieces of data, the median is one of the data points. And so here, if you have 9 scores, we know 9 plus 1 is over 2. Let's get rid of that there. 9 plus 1 over 2 is 10 over 2. It's a 5th score. It's actually one of the scores themselves with 4 below it and 4 above it. Okay, for an even number of data points, like let's take 10 scores, if we work out m plus 1 on 2, that's 11 on 2, it's a 5.5 score. You can't have that. So it's halfway between the 5th and the 6th score. Add them up and divide by 2. Find the mean or the middle point of the 5th and the 6th score. So for an even number of data points, it's the average of the 2 middle values. It may not be one of the original data points unless the 5th and the 6th score are the same as each other. Okay, so here you are. Here's the basic idea. Now we'll use a formula for either set of data, odd or even. You add 1 to it, divide by 2, and that, if it comes to an exact score, there it is there. If you have n plus 1 on 2 and it comes to a fraction, it's between, that's in an even case, you go from that score, halfway between that score and the next score. Okay, so we're using this symbol now. You might remember way back at the beginning of the last video where we had symbols, and that was one of them actually. The idea of the average of the 2 middle data points in an even set of data. I didn't actually go through that, but now you can see where it's coming from. All right, what about the mode? The mode is the most frequently occurring value in the data set. So we've seen that before. Bit of a problem using the mode sometimes because often there's no score that occurs more often than another, or there might be 2 or 3 scores all occurring at the same number of times. So there might be more than one mode. So it sometimes is not the best measure of centre because it's a bit confusing having more than one mode. Okay, let's go on now. Let's have a look at how we can use this. Number of games won by a football team over 9 seasons is this here. Okay, so there's 9 seasons. Find the mean. Well, we're going to put X bar, so I'd rather you put X bar over there. It's always good to start the problem with X bar is the sum of all the x's over n. So it's going to be 55 over 9 and approximately 6.11 wins. In other words, we generally round off to 3 significant figures. So take the first 3 figures, look at the next one. If it's 5 or more, take the last one up because that would mean that last figure was closer to the next value there. Okay, Now we want to find the median, so you must put the data in order. Okay, so 9 scores, so 9 plus 1 is 10 divided by 2, so it's a fifth score. It stands out by itself. That's the glory of an odd number of data points. One of the scores themselves is the actual median. So the median is 6 wins, and the score which occurs the most often is 5. So just go through and see up here that there are 3 5s there. That's pretty easy. All right, are you ready? Let's have a look at the range. The range of a data set is the difference between the maximum and minimum values, the highest minus the lowest. So this gives you an idea of how spread out the data is. So the number of bedrooms in the house in a street listed there. What's the range? You've got to find the lowest one. There it is. You've got to find the highest one. There it is. So the range is highest minus lowest, which is 4. You get it? Bit of practice, really. We've done all this before. Okay, so try your hand on this one, 18D1. A few questions here. Pause the presentation, have a go, but look ahead at the answers every now and again to make sure you're getting it right. Okay, so all done before. The important thing here is to be able to put the data set in order when you are trying to find the median. Okay, so that's going to be fairly long down here, isn't it? Fairly involved down there. So just watch that one. All right, let's go on. Another example here for you with using a dot plot. We don't see these very often, but they're fairly easy to understand, where you've got the score down the bottom. You don't have any side scale here, but you simply have dots for every data point in each of those groups. So sort of similar in a way to a stem and leaf plot, but you haven't got the actual data points, so you've lost those. So here, to do this problem, we want the median and the mean. You need to list the data points. So you need to go through and say that's 1 5. There are 4 6s, so you list them down. There are 3 7s, so you list them down. So you can see a dot product has basically, has basically got all the data points in order. 4 8s and 1 9, let's go back, 1 9 and 2 10s. Okay, so just go through. So finding the median, now we've got them in order there. You'd say there are 15 scores. 15 plus 1 on 2, 16 on 2 is 8. So one of those 8s, that one there, is the middle of the data point. So, sorry, not the one of the 8s. The 8th score is the middle, and the 8th score, just totaling them up here, the 8th score is 7. Okay, this is the number of the score. I nearly did the wrong thing myself there. The 8th score, not 8 as the score. So actually the 8th score is that 7 in the middle, right there. Okay, so the median is 7. To get the mean, remember the formula. X bar is the sum of all the x's, the data points, divided by how many there are. So we add them all up, 111 over 15. You don't, and you're going to have exactly, it comes to exactly 7.4. You don't need approximately there, because there's a terminating decimal. It stops, doesn't keep going, so you don't have to round off. All right, get the idea. Let's keep working. So here we are. Here's some for you, and here's one that I was asking you before. Get rid of that. Here's one I was asking you before. How would you find the median from this data set? Just keep in mind it's already in order, starting at 21, 23 up to 57. So you've already got it in order if you can work out which score you want there. And don't forget the scale down the bottom. But yeah, so think about that one. You might talk to your classmates and your teacher about how to count up the positions there on a ordered stem and leaf plot. That's why it's very, very important to keep the stem and leaf plot ordered. Okay, ordered stem and leaf plot. So the median is easy to, relatively easy to go through and work it out. Okay, have a go. We'll go down to some answers in a minute. A little bit more, a little bit of a twist on the mean here. A set of 7 data values has a mean of 9. Find the sum of the data values. Okay, so just remember, x bar is the sum of all the x's on n. So if I know the sum of all the x's, or if I want the sum of all the x's, if I know those two, I should be able to work it out. I know the mean is that the sum of all the values divided by 7. So if I'm trying to find this, it's been divided by 7 to get the answer 9. What was the total? We'll do the opposite. We'll multiply by 7 to get that sum of the data values. Okay, so what's been done to something that's missing and you've got an answer, has to be reversed to find out what it was before that was divided. So here it was divided by 7 to find out what the original value was to get 9. We will multiply by 7, go in reverse to find out what that original value was. So that's some basic algebra, isn't it, that you should have done by now. All right, let's go on. Here's some questions. Just watch out for this one down here. This is a good challenge question. Question 10, it's in red. So I want you to really think about that. Try to build up your ability to think, your grey cells, and see what you think. Okay, so that's a bit of a twist on the mean there. Okay, so pause the presentation, have a go. Now I'll give you all the answers. Okay, there's a bundle of answers there, right the way through. And I want you particularly to think about question 10. Bit of a challenge for you as a budding young mathematician there. So might have to talk to that about that with your classmates and your teacher, how you do that one. Okay, let's go on. So we obviously now want to talk about taking calculations from a table, and we've done a bit of this before. And remember here, the center and the spread, when you have a table, we usually put the score, the frequency, and this would be an FX column, the product of the frequency times the score. Because when you have, let's take this line down here, when you have a data point of 5 and you've got 3 of them, you don't want to do this. Okay, multiple addition. You're going to do multiplication, which is where the word comes from, is multiple addition, where you're timesing rather than adding up over and over again. So that's one form of multiplication. There are multiplications of other things which don't represent multiple addition, but in simple number sets like this, that's what they mean in the real number world. All right, so you're going to multiply all those out. So don't forget to do this, because a lot of people just want to add up this column. Hey, no. They occurred many, many times each. Okay, or some occurred more than once is the most important thing here. So your total would be much larger if you take account of the fact that there were 7 6s, 15 7s, 8 8s, and 5 9s. Overall, there's a big number here. So x bar would be the sum of fx. I don't like that keeping on going there. We'll just get rid of that. It is the sum, hang on, I got this now, sum of fx on n, which is all the f's times the x's, big total, 278 on 40, which, can you do that? What is that? 6.95 exactly, I think. Okay, you might have to check that one on your calculator. Okay, now let's come down to how to find the median. We're going to go here. If you look at, there's the frequencies. So in that first group, there's 1. In the next group, there's 1. But therefore, there's a total of 2 scores up to the end of 4. So we are doing something which is accumulating. Accumulating here, went a long way here. It's accumulating the scores here. Oh, it's doing funny business here. All right, so it's accumulating the scores so that we can actually see, wrong way now. Okay, we can actually see how many are less than a particular score. So 5 are up to the end of 5, 12 are up to the end of 6. Adding them on, aren't we? So adding that on, 27. So we're accumulating all the frequencies up to the end of the score. So we add that one to that one and get 2. Then up to the end of that, add 3 to that. So we're totaling them. We're adding more and more on as we go. Okay, so what do we want here? We've got 40 scores, so the median is the 40 plus 1 on 2. Okay, 41 on 2 is 20.5. So it's halfway between the 20th and the 21st. And we want to go here, divide by 2. Okay, so halfway between the 20th and the 21st. Well, where are they? There's 12 numbers up to the end of 6. There's the score. So the next 15 up to the 27th score are all 7s. So these two are both 7s. 7 plus 7 on 2, so the answer is 7. Okay, so they're both 7s, so the answer is one of those 7s, if you like. So that totaling up the frequencies or accumulating the frequencies, called a cumulative frequency column there, helps you find where the score is up to that point. So that's a little trick we'll need to use. Let's go and use it now. So let's have a look at this one. We've got this, keep doing that, you can't touch the screen so hard. So there you are, there's a frequency table, and we want to calculate everything about it, the range of the scores. So first of all, we're going to do x bar is the sum of fx on n, and so we've got the products over here, frequency times the score. There they all are, because each of these scores are occurring a different number of times. So the first thing we might do is add this total up here, because there are 30 people, total frequency, of 20 people. And then we're going to total up this number here, because it's the sum of all the frequencies times the scores. And so sum of them, divide by number, 157 over 20, which is approximately 7.85. No, it isn't. It's exactly. It goes exactly, so we don't need approximate sign there. It's 7.85. Okay, so our sum over our total number of scores would be 7.85, would be our mean. Okay, so now let's work out the median. So with the median, there are 20 scores. Shouldn't be doing that. Okay, so there are 20 scores. N is 20. N plus 1 on 2 is 21 on 2, or the 10.5. Halfway between the 10th and the 11th score. 10th score and 11th score divided by 2 is the median. And now we've got to work that out. So let's go and find it. We've got 1 in the first group and 2 in the second group. So there's 3 up to the end of that group, 4 in the next group. So there's 7 up to the end of that group. And then adding the next one on, 7 and 7, there's 14 up to the end of that group. And there it is. So there are 14. So all of those scores from the 8, there's 7 up to the end of that group. So the next 7, that's the 8th, 9th, 10th, 11th, 12th, 13th, 14th student, are all 8s. So what's the answer? They're both 8s, the 10th and the 11th student. So the median is one of those 8s, if you like. Well, halfway between 8 and 8 is 8. So the median is 8. So you get the idea. This time they haven't shown that cumulative frequency column. You're just doing it in your head, if you like. working out where the two scores lie that you want, in which particular value there. Okay, so what is the mode? We've got to go through, let's tidy this up a bit, go through and find the one that occurs most frequently. So the highest frequency is 7. So the mode is the value that has a frequency of 7, which is the number 8. So now we want the range. The range is the highest score minus the lowest score. 10 take 5 is 5. Okay, so we could write the mode out as 5. Interesting enough, quite a little bit of manoeuvring to do there to find those statistics. Remember, we're calculating values to just try to describe the centre or the spread of the data, and so those values themselves are called statistics. So the mean, median, mode and range are all statistics calculated on a data set to describe something about it. Okay, let's go on. Here we go. Your turn to have a go. Here's some questions for you. And there's some answers. Okay. So see what you think. Are you getting some right? Might have to check with your teacher and your classmates about that. And perhaps go back over and have a careful look at those examples again. Let's go on. We're going on to the last section here in the Year 8 section on statistics in the national curriculum. And we're going to talk about data collection. Okay, so we've seen a little bit of this before in an earlier presentation. But so we need a problem which we're going to try and solve by collection and analysis of data. That's the definition of statistics. This is the statistical process here. And we're going to pose a question. So you've got to pose the correct questions. What do you mean by correct questions? Well, I don't know which comes first here. We start off with those questions, and making them correct, I don't know, goes hand in glove with whether you're going to collect data or not, how you're going to collect data. But we've got to collect data from the target population, whoever that is. It gets harder and harder if we want to know what everybody in Australia thinks, because it's hard to get out and find a representative group, and you can't do a census. There's too many people. It'd be too expensive to get in touch with everybody. So we've got some problems there, haven't we? We've got to organise the data. That's what we've been doing. Summarise and display. So we should be getting pretty good at this now. Analyse the data and make a conclusion in the form of a conjecture, and then write a report. Now this word we haven't seen much before, conjecture. So if you're taking a sample, okay, if we're taking a sample, so this is what we're doing back here, collect data from the target population. If it's not the whole population, any conclusions we make are only conjectures. That's proposals, if you like. Or this is a hypothesis. That's what we think. We don't know for sure because we haven't done the whole population. So we're talking about sampling here, not taking the whole population, but taking a sample from that target population, and so we can only make a conjecture. So the best mathematical term for our guess or our proposition, what we propose or our hypothesis, is we make a mathematical conjecture. We reckon we've tested 15 motors, and on the average they will go 120,000 kilometres without any problems. So that's our conjecture. We can't say that for sure because we didn't test the whole population of motors. Get the idea? Okay, come along now. And here it is, of course. The motors are back again. From an earlier presentation, we talked about testing or collecting data from every individual in the population. And the population here was all the motors that the company had made, and it keeps going. And you would not, for example, do a census on this, because to find how long the motors run, you would have to wear them out and then they'd have nothing to sell. So what do? You take a sample of motors. I've got 10 down here, and of course the question is that enough? Or is that representative of the whole population? So you're going to take a part of the population and make some conjecture. This is going to imply something about the whole population. This is actually called an area of mathematics called inferential statistics. Inferential. You're making some inferences about the whole population based on a sample. All right. Okay, so how do you do it? Characteristics of a sample. It must be, here's a crucial driving force, it must be representative of the whole population. You're trying to represent every different member there, all the different motors made, all the different people perhaps who you're trying to find an opinion from, and you must have no bias. So it wouldn't be any good, let's say you're wanting to talk to a range of people and you're in a city street with your survey forms and you go up to people and you talk to them, and you might say, well, I think older people have a better opinion, so you start just talking to older people or younger people or in the middle, or you like the way the person is dressed or something, or the way they look, and so you start talking to those people. Now that's biased. You've got to give each member of the population a chance of being involved without bias. So that's the idea, where you're taking a sample which is somehow favouring one group or another. So I'll put that down. Do not favour a group, a particular group. Do not favour a particular group. Okay, I hate that going on there like that. So we'll go this way. So do not favour a particular group. That's what we're trying to avoid, is any bias. And sometimes it's hard. You might not realise you are actually doing it. So we have to set up our sample very, very carefully and structure it so that there isn't any bias. And then, of course, this is a very vexing question here. How much is a reasonable sample size? So I don't know. If you've got everybody in South Australia, which is millions of people, how do you get a representative sample size? Would it be 500? Would it be 1,000 that you should talk to? And how would you collect it from all around the state, giving every group a chance? You couldn't go to a mall in a city, in the city somewhere, because what about country people? Wouldn't be represented sufficiently. It's got to be representative of the whole population and sufficiently large. So this is going to be something that we're going to work on with your future study in statistics, and it is quite a challenging question there. And there are ways in which people have tried to estimate what is a good sample size. A fairly complicated area of statistics there. All right, let's go down and see if we can have a look at some of these ideas. Okay, so Ellen wanted to know the mean height of the Year 8 students at her school. She measured the students in her Year 8 class and obtained these results in centimetres. So she took her class. Use this sample to estimate the mean height of Year 8 students in the school. Do you think the estimate will be accurate? Explain your answer. So that's your conjecture here. Okay, so your conjecture is the estimate. You're going to say, on the average, we think this is the height of the Year 8s. Okay, so here we are, X bar. Okay, we can't do that. Let's go here. X bar is the sum of all the students' heights in the class divided by n. So you put them all down, divide by n, and you get a mean of 156 centimetres. Okay, so the estimate is 156 centimetres. That's our conjecture. That's what we reckon the average Year 8 height is. Some above, some below, and that's our mean. Now, is the sample, do you think this estimate will be accurate? Okay, so down here they've got an answer. The sample is of reasonable size. There's a whole class, 30 students. There's no reason to accept any height bias between the Year 8 classes. Okay, so this estimate should be accurate. So notice there we're looking for bias as well. There's only one problem with this, isn't there? How large is the school? So is 30 enough? What about if it was a huge middle school campus, 7, 8s and 9s, and there was 1,000 students and there were, well, I don't know, 400 year 8s. Huge middle school. Okay, maybe that's not a reasonable size. Okay, maybe that isn't, depending on how many there are. But in your usual school, I suppose, go along and take one group. But the other thing is, how do you know it's not biased? Is this group of students, in some schools, groups of students in year 8 are grouped because they're subject combinations. So what if the subject combinations gave a bias towards boys or towards girls due to their subject choices in that class? So there could be some hidden bias. We've got to know that that is a class which represents, remember this from before, is representative of all of the year 8s. Now, due to subject choices, some home groups in larger schools have different interests, different numbers of boys and girls, for example, and that might give might give a bias towards one or the other in height. Okay, so you've got to think about that. There's no reason to expect, but you might have to take precautions to make sure there isn't a bias in that sampling process. Okay, so there's a lot of thinking to do here. It's not as easy as you might think. You have to think about it. Anyway, let's go on. And so here's your last little set of questions here in 18E. State whether a censor or sample, we did this before, and then we're going to think about in here bias and numbers that we would try to get to do a reasonable sample to represent the population, to make a conjecture about it, a proposal about what the whole population is doing. All right, so think about this, quite interesting stuff now as we get into the more practical uses of statistics. Okay, so here's some more here. I think that's the last of them, the 7 questions to finish you off on looking at sampling or censoring, or you can't have censoring, sampling or conducting a census. Okay, are you sampling? If you are, have you got a representative group of the whole population? Is there no bias? Have you got enough? Okay, pause the presentation and have a go. And here are your answers. So that now completes the series up to the end of year 8 for the national curriculum in statistics. So I hope you've enjoyed that. I'll catch you in a further presentation. Cheers for now.